All right, we should be getting started now. Welcome. I hope everyone has had a great summer so far. Actually, looking at those numbers, we're going to be talking about some meteorological summer numbers. So that actually runs June, July, and August. We do this because it's easier to keep track of the data. I just wanted to start with some cooler things to consider before we look at the summer numbers, though. Kind of nice to remember that we do have snow that does show up occasionally in Arizona. And we do know that Belmont actually cooled down to freezing last week. So that's always good to see. We like seeing that. But this is where we're going to get started. So unfortunately, this summer was the hottest summer on record for Arizona. June was the second hottest, July was the second hottest, and August was the fourth hottest on record. But taken together, that made Arizona's meteorological summer the hottest on record. And the records go back 130 years. You can see where many cities and towns in Arizona, the Southwest, the West, hit or tied their hottest summers on record. Those are the cities and towns that have the dark red squares on the map. And then let me change over a little bit and we'll take a look at the West and the Southwest, looking at the climate regions. And you can see here the Southwest is Arizona, Utah, Colorado, New Mexico. The Southwest climate region hit its hottest meteorological summer on record. So it's been a hot summer. It was also a really dry summer for Arizona, landing as the 41st driest summer on record. So the numbers have been something else this summer. I think we all kind of know that. We look at the numbers for Phoenix because those numbers tend to be the hottest temperatures that impact a lot of people. The first numbers that I pay attention to are the number of days for the Phoenix weather station that have had a maximum temperature of 110 degrees or higher. These temperatures can absolutely put people at risk from heat-related illnesses. So in the early 1900s, Phoenix used to have on average 5 days a year of 110 degrees or higher. The last decade that I calculated, the average was 27 days of 110 degrees or higher per year. That statistic included the first time that Phoenix hit 50 days or more of 110 degrees or higher. That was in 2020. 2020 had 53 days that were 110 degrees or higher. So unfortunately, we seem to be hitting a new threshold. This year, we hit 61 days. You can see that 2023 hit 55 days. So looking at just the last 5 years, the average number of days in the last 5 years for the Phoenix weather station from 2021 to 2024 has 40 days on average. So that's an average number. So unfortunately, we're seeing those numbers going up. And then these numbers also we pay attention to. This year gave Phoenix the most number of nights that didn't cool off below 90 degrees. So that was a total of 39 nights this year so far. But hopefully we'll be at the end of that, or very soon we'll be at the end of those hot nighttime temperatures. I don't usually count how many days in a row have 100 degrees or higher for the Phoenix station, but this year we just didn't get enough storm activity at the Phoenix station to be able to drop one day below 100 degrees. And so days with 100 degrees or higher ran from May 27th to September 16th at the Phoenix weather station. That was a record number of days in a row. Phoenix can still reach 100 degrees or higher through most of October. Just heads up, everyone. Last October, so 2023, had 12 days of 100 degrees or higher. And for Phoenix, the overall record number of days for a year with 100 degrees or higher is 145 days. So that happened in 2020. Here's hoping that we don't break that record this year. So we knew August was hot, and looking at Apache, Maricopa, Yuma counties, they all hit their third hottest August on record. Coconino, Greenlee, La Paz, Navajo, and Yavapai had their fourth hottest August on record. Looking at, we did see some precipitation in the northern counties in August, so that was a good thing. but Coconino was the only county last month that had above average precipitation. So for August, Santa Cruz had its 10th driest August on record, and La Paz and Yuma both had their 12th driest August on record. Unfortunately, September so far has been hot and dry. The end of September is the end of the monsoon season. It's also the end of the water year, two really important times when we do a lot of reporting to understand what's been going on in the state. September numbers are unfortunately going to be impacting those reports as well. This year has been an active wildland fire year for Arizona. These numbers start with the calendar year, so January 1st. Last year had a lot of small events, but nothing was really exceptionally large last year. This year, there's been a lot of activity. Every month of the year so far has had activity. And that activity, looking all told to date right now, has been 60% more active than all of last year. There's still active events right now, and it's certainly possible for those numbers to increase through the year. Taking a look at the water year so far, you can see that those hot months have been going just about every month since the start of the water year. It's actually been the sixth hottest October to August on record. The water year starts October 1st, it runs to September 30th. So unfortunately, so far, there's been overall less precipitation across the state. It's been hot and it's been dry so far, October to August. And here's the numbers that we pay attention to when we evaluate statewide drought. While statewide precipitation was actually above the average water year precipitation through June, we were doing okay through June. July and then August have now dipped below the long-term averages. That means our water year 2024 will probably be another year below average. That would bring 21 years in the last 31 years to deficit. So 21 out of the past 31, that's what we're expecting to see. We'll have to wait and see, throw in the this month's information, but we'll see what we get. Short-term drought is starting to be impacted by areas in the state that didn't reach the normal amounts of monsoon precipitation. So that largely was along the western counties and the central counties, including Maricopa County. You can see that the orange color there in today's map, that D2 severe short-term drought, that has actually started increasing across the state. So it started increasing last year. And that was the first time we were seeing that increasing since April. Arizona's been in a long-term drought since 1994, and the impacts to Arizona's drought they're not from lack of precipitation only. Our state is really also impacted by hotter than normal temperatures, and hotter temperatures influence evaporation and transpiration. Those processes remove water from the soils. You can see where Maricopa County and Santa Cruz County are both dealing with that really dark, exceptional long-term drought. Unfortunately, it looks like the monsoon and the water year will both end warm and dry. So what we're looking at here is the 8 to 14 day temperature outlook, 8 to 14 day precipitation outlook, and it takes us through the end of the month. And so it's looking like it'll end hot and dry as well when we get into October. This is looking at the seasonal outlooks. And so seasonal outlook that we're looking at here is taking into account October, November, December, and unfortunately also expecting us to stay hot and dry. That's not to say that we can't cool off and have some storms. We absolutely can. Although we're entering a climatologically dry portion of the month, storms can start picking up in December, but every year is different. And this is one of the reasons that we pay attention to understand what's happening with that winter precipitation. It's been a very long transition from El Nino to La Nina, and it's still transitioning. There's a better chance now that La Nina will start at some point before November, when we look at that, La Nina statistically means that Arizona has drier winters. But again, that's not a forecast, and we'll have to wait and see what ends up happening. So I want to invite everyone to our webinar next month. Dan Hens of the Flood Control District of Maricopa County will give us his monsoon wrap-up report. I'm telling you, there were some good things. So you might want to come back and see that. That'll be good to hear. And I want to introduce our guest speaker today. Our guest today is actually from our sister National Weather Service office, Las Vegas. Vegas is charged with forecasting for a lot of places. You can see they're into California, into Arizona, and Nevada. And they run into Mojave County for Arizona. So we actually have 4 National Weather Service offices that contribute to Arizona. Please welcome Dan Burke, the warning coordination meteorologist for the Las Vegas National Weather Service. Thank you very much, Dan, for your time. We're glad to have you.
Thank you for having me. Let me share my screen here. All right, you should be seeing my screen now, I think.
Looks great.
All right, thank you. Again, I am Dan Burke. I'm the warning coordination meteorologist for the National Weather Service in Las Vegas. So I'm going to talk a little bit about the extreme heat we had in our area of responsibility, which is this is where we cover a good portion, all of southern Nevada, a good portion of the desert area in California, and Mojave County in Arizona. And to put it into perspective, where Arizona is, there's where we are, and we just cover that northwest corner. So it was hot all over, as we kind of can tell. This was a hot month or a hot summer, and in the Southwest, no less hot than anywhere else. It was very hot. In fact, a record heat. In these areas, where I just chose to select data. Death Valley and Las Vegas and Kingman, Arizona, as well as Phoenix, all had their hottest meteorological summer on record. Vegas had their hottest June and July on record. And this says a lot because, these are all hot areas. We actually hit 120 in Las Vegas, which had never happened before. And we always joke that, maybe we're gonna be the next Phoenix, but because Phoenix is the only major city that's hotter than Vegas, but we got a long way to go to catch that, catch you in Phoenix. Death Valley is interesting to note because while it was the hottest, and Death Valley is known as the hottest place on Earth, and it was hotter this year than any other year. However, we've hit 130 in Death Valley twice in recent years, in 2020 and 2021, but we didn't hit 130 even during this long heat stretch that we had. I'll talk a little bit about why that might have happened here. And Kingman is generally cooler. They're up at about 3,500 feet, but still, it's all relative. They still had their hottest summer on record for them. So I'd like to mention a little bit about why it's been hot in Las Vegas relative to other areas. I get calls from grad students telling me that they want to use Vegas data for climate change studies for their dissertations and such, and I tell them stop right there. Vegas at this point is not a great place to gauge climate change and global warming. As you can see in this graph, this is this year's high and low temperatures in the dark blue, and the goldenrod there kind of color is the normal high and low, the climatological normal, the 30-year period from 1991 to 2020. The red line there is the record high temperatures for those dates, and the blue line, light blue area, is the record low temperatures. In a normal year, we have a climate record that dates back to 1937. So we normally will tie or break a handful of records every year, high temperature records every year. And you can see by this, we've done that this year too as well. We've hit some record high temperatures on daily record highs. We have not hit a record low temperature in Las Vegas since June of 1999. 25 years since we've had a record low temperature. So To say that it's getting warmer is absolutely reasonable, and the data bears that out. But it's primarily due to the low temperatures that are much higher than they once were, and a big reason for that is urbanization. We've done, I can't, not saying that global warming is not happening. It absolutely is. But how much you can take the data and decide how much, separate the wheat from the chaff, how much of it is global warming and how much of it is due to rapid urbanization. It's tough to do that. At some point, we will stop building, and once we've stopped building and run out of room to build, then we'll stabilize, and over the decades following that, we'll be able to have a much better indication of how much global warming is impacting Vegas specifically. But regardless, for those of us who live here, it's getting hotter. What doesn't matter what the reason is, it's getting hotter, and we have to deal with that. So this year, we'll go in some of those datas now. Now, some of the same kind of data Dr. Stefel is talking about. We have 36 days this year where we were over 110, which again is not horribly out of the range, but it's still a record. And our days with a max temp over 100 have reached exactly 100, although we may break that this week. But good to note on the right there, we have our 4 hottest temperatures we've ever recorded all occurred in that 1 week in July, where we had our hottest temperatures of the year. We hit that 120, a 119, and 118 twice, and that was unprecedented. We had hit 117 5 times before, and we could never break that 117, and we broke it wildly. The question was why. Death Valley didn't hit 130, and Kingman, while it set all sorts of records, didn't quite get to its all-time record. So why did we break our all-time record so significantly for such a long period of time? There are a lot of reasons we're thinking about that, but one that has, we were in kind of a perfect storm where the bubble of high pressure that was sitting over us that week was really sitting right over us, which can make a difference of a few degrees between here and Death Valley and for Kingman, compared to our normal. However, we also have in the last few years have been on a crusade, if you will, to reduce the amount of grass that we have at homes in order to save water. So we've been changing over, we're getting rid of our grass and getting to more of a rock desert type of landscape. And though as much as the grass saves us some water, losing the grass saves us water, it also was retaining water and helped keep the temperatures down cooler. We're looking into some research with the Desert Research Institute right now in order to see, how much of an effect that may have had. And I'm really looking forward to seeing the result of that research. But it'll be, it's interesting. This is just our hypothesis at the time, at this time. So we'll see. And we also issued 6 excessive heat warnings, totaling 29 days in over our area. And that is also a record, the most days we've had under excessive heat warnings. This is heat risk. If you're not familiar, I will try to get you familiar real here. Heat risk is an index that's been worked on for the last decade here in the Western region. It was started by someone who worked in the Phoenix office and the Vegas office at some point, who went up to our regional headquarters and now have implemented this region-wide. In fact, this year, it was implemented nationwide. You'll hear this conversation about heat risk and heat index and wet bulb globe temperature. Those are all ways that we try to communicate how the heat is affecting individuals. They all work a little different way, but heat risk is something that was developed in the West for the West, and it does really well in the desert areas here. So what we're looking at here is an image of the dates so far this year and what level of heat risk they were at on those given days based on the temperatures. And this is a little bit to describe what it's like. Risk of heat-related impacts. Those in the green category are no risk from expected heat. In the summer, we're never in the green category in the desert. We're at least in the yellow category, which is minor risk of heat-related impacts, or orange is common throughout there. Once we start getting into this red level, the major heat risk, that's when we start strongly considering issuing our excessive heat products, our excessive heat warning. And extreme is really not necessarily a higher magnitude of heat than red, but the magenta or extreme level really indicates that we're not getting that relief overnight. We're not getting the relief overnight, and we're having a longer duration heat event. And if you have multiple days of red, we'll put in magenta to to identify that it has a cumulative effect. In fact, Dr. Savell talked about how many 90 plus days for low temperatures that were in Phoenix. Yeah, we had 22 days in Vegas where the low temperature never got below 90 degrees, and that destroyed our record. Previously, our record was 8. So it was extra hot overnight. So when we saw a record amount of heat-related fatalities, unfortunately, a couple hundred of them here. I don't have exact numbers, but it was well over 100. So it's this is a huge problem. How do we mitigate that? So this is what the map looked like during that big heat wave that we had in July. A lot of magenta all over our area. And this was when we had that 120-degree temperature. It was just nuts. So when you log into this page, when you go into this link that's here on the lower right, this will take you to a national map, and you can zoom in anywhere you want. It's really slick and easy to use to see what locations will have the highest heat risk. You can zoom in almost down to the street level to see what we're expecting. However, again, these are done in grid boxes. You can see they're kind of pixelated. That's because these are locations that are, so you're going to be real close to that. But it's not necessarily pixel to pixel perfect. This is based on our forecast, along with climatology, along with what we know about heat-related fatalities and morbidity and mortality. And this is all done in the background. And we're also now using CDC data for social vulnerability. So in areas of town where we know that people have better access to air-conditioned spaces, and for example, in parts of town, you've got people who have more means. They can, if their air conditioner goes out, they have the means to go to stay at a hotel or to repair their air conditioner immediately. Whereas perhaps other parts of town, people aren't in that position, and if their air conditioner goes out, they're stuck there without heat. This also takes into consideration some of that type of data. So it's really pretty robust. And now this is, again, a nationwide. It's available for nationwide. So go ahead, check that out. It's really useful, and it can help you make decisions within your organization. We have a lot of people who decide, we've got in Mojave County, we've got the Public Works Department. They make decisions on how they will work on projects out there. They don't want to have their employees out there working in red heat risk. So if we can give them this in advance notice of this, and they look at this and they say, well, 3 days from now, we're going to have red heat risk. They plan better, and they say, well, they're going to work on tasks in the shop as opposed to out on the road that day. So that's just an example of how it can be used, but it can be used by anyone for any reason. It's a really valuable tool. So what do we do with our partners when we expect this kind of heat? In this case, we'll put out social media posts. We'll have meetings with our partners. we'll have meetings with them to let them know this is really important, this kind of heat, and could be very impactful. And as a result, they will open cooling stations. Now in Vegas, we have cooling stations open all summer, but not that many. When we issue a product, or when we really raise the awareness of the heat that's coming up, they open up dozens and dozens and more. I mean, when I'm showing you here on the left, there's actually an entire second page with a list of with more lists of more sites that they have cooling centers for. So this is what we do with it. We also work with the Desert Research Institute and UNLV, and we research on this, and we're researching how we can better serve. First off, why does it happen? How does it happen? But on top of that, how do we better serve underserved communities? We have a large population of those experiencing homelessness in Las Vegas, and many of them take refuge in our flood control tunnels, which are considerably cooler than they are out there. However, our hottest times of the year also happens to coincide with our monsoon. So this year we're fortunate or unfortunate. We had a very, very dry monsoon. Vegas, we only got 0.08 of an inch of rain all monsoon, and while it's not quite over, it's essentially over for us in terms of the thunderstorm activity. So I don't expect it to increase. But we get about an inch of rain during the monsoon, and we got only 0.8. So that was 0.08. Sorry. So it was very dry. But normally we're concerned with floods running through those channels as well. So it's a double-edged sword. We don't want them in there, but we understand that's why we encourage people to go to these cooling centers. And how do we get that information to them? We, as best we can, with social media, with homeless advocacy agencies, will go down and work with the homeless. They will announce to them, go down in the tunnels and tell them, hey, you need to, here's some information on what you can do to be safe at this time. What's coming in the future? All indications are we're going to continue on this path and just heat up unless we do something really drastic. And even if we do something really drastic to limit the amount of carbon we're putting out there that will heat us up further, we're still going to heat up a bit. So best case scenario, we're still going to continue heating for a bit, and the mitigation needs to start soon if we want to limit that even further. So this is I'm going to talk quick about some changes that we're making in the Weather Service. Beginning in October, we will no longer be issuing wind chill products. They will be consolidated into products called the extreme cold watches and warnings. Watch means we see it coming and it's coming. We're giving you a heads up. Warning means here's where we're really confident it's going to happen and when it's going to happen. And wind chill advisory for areas that use that product will be renamed to the cold weather advisory. And that's for this winter. For next year, we're just changing the name of it. We call it excessive heat watch and warning now. They're going to be called the extreme heat watch and warning next year. So that's just a tiny change, but it's something to note. So this is the contact information for Vegas area for me and for our office. But if you just put www.weather.gov/Flagstaff or Tucson or Phoenix, you'll get the local office for that area. Or you just click on www.weather.gov and then just click your location on the map, and it'll get you to the correct Weather Service office for your area. Facebook.com. Again, we're on Facebook. You can go to NWS Vegas, NWS Phoenix, NWS Flagstaff, NWS Tucson. You'll get to the right office. And Twitter, I still call it Twitter, but X/Twitter, same kind of thing. This is a naming convention used by all the offices. And this is our local office phone number if you need something, particularly from Mojave County, or if you're just coming over to Vegas and want to know the forecast for your drive here, let us know. And there's my contact below. I want to thank you for listening, and I'll be happy to take any questions if we have some time.
Oh, goodness. Thank you, Dan. That was amazing information. Really appreciate what you do and what you contribute to people in this part of the country, and especially us down here in Arizona. Glad you didn't join the 100-degree plus month club that I started last year. But this summer was really, really hot. You're right. Those night temps are really driving those average temps, and we're seeing that a lot. So I'm grateful for your time. I'm going to go ahead and stop the slides, and we'll get this recorded and get this up. So thanks everyone for coming.